You're watching video E4.p2-18, which is notes, air masses, and the jet stream. What you're going to be doing is going over kind of the learning target, E4.p2-F, which is describing the actual characteristics and movements across North America of all the major air masses and, of course, the jet stream. Alright, so we'll go ahead and get started, jumping right in, talking about air. The first thing, which is kind of a review, we talked about this a little bit earlier in the year about what makes up the air that surrounds Earth. So air is mostly made up, of a gas, and basically is suspended in our atmosphere. The different types of gases. This is actually one of those things that sometimes when I'm up late and I'm just flipping through and watching late night TV, Jay Leno has one section that he talks about. Where he goes out onto the street and just asks some people, people like you and me, sometimes some easy questions that you would think people would know the actual answers to, and it's quite funny at times, some of the answers that these people actually come up with. Like, for example, who is our current president? And some people don't even know who that is, or will give an answer of a president that was a number of years ago. Well, I remember watching a couple years ago where they had this portion of a show called Jaywalking, where he asked, what's the most common air type of gas found in the air that surrounds Earth, and the majority, surprisingly, the majority of people thought oxygen was the answer. And as they then go to the end of the show talking, like telling the people the answer, and people are like, the response is like, then how are we breathing? Well, you have to keep in mind that the Earth is quite huge, very large, especially for those that have hopped in an airplane and traveled across the country, or even maybe to other countries as well. If you're in an airplane traveling at anywhere between 400 miles an hour, you can, it's a long distance. Earth is quite large. So oxygen, even though it's at 21%, if we round it, it still is a large amount of our gas that we find in our air. But nitrogen is number one. Nitrogen is the most abundant gas we have. And then argon, carbon dioxide, and those of you that are greenhouse gas believers talking about global warming and the reason behind it, or those that would see this and go, well, it's not that big of a deal, it doesn't make up a lot of it. Nonetheless, it still is a significant amount, and that number is increasing. And then we also have things such as water vapor and other small gases as well. So let's get into talking about how that air is then formed into what we call an air mass. An air mass is simply a very large body of air that is characterized by, number one, its temperature, and number two, the moisture that is involved. Is it dry or is it humid? And basically, as it says right here, these things can cover thousands of square miles. So, big portions of, our country, or big portions of our world at one time. And there are different types of these air masses, and how we know the difference between them is, number one, the temperature that they bring, and two, the type of moisture that they bring with them. And that's part of the reason why we have different types of fronts as well, because those fronts will determine, what happens to our temperature, as well as the type of moisture that accompanies it. In this little map right here of the world, you can see some specific places, and you'll see some examples. As it says right here, is an MP air mass, an MT air mass, a CT. There are CP and CAs found all over the place. Now, we'll talk more specifically what CA stands for, and CT, MT, and all these different things when we start talking about the moisture content. Okay? And along with the temperature. We'll start with moisture. When we talk about moisture, the air mass that comes can be either dry or moist. Okay, so it's either going to bring moisture with it, or it's going to bring nothing, and the air is going to be not as humid, not as moist. So how do we know if it's dry or moist? It really depends upon where it's located. As you might be able to gather some information if I asked a simple question, if living next to Lake Michigan, would you assume that most of the air masses that we get are dry, aka not a lot of moisture, or moist with moisture content, a lot of moisture in it? And most of you would say, well, we're right next to a lake, so it's probably going to have a lot of moisture, and your answer would be correct. But again, the air mass in the moisture depends solely where it is located. So are you near water or are you away from water? And there are two terms that are used to describe moisture content, and that is maritime and continental. We'll talk about those terms in just a few minutes. Okay? So when we talk about maritime, maritime is the letter M, as I was describing earlier in this diagram right here, with like MT as an example and MP. Maritime, meaning that it comes over water. Mara, marine, and these types of air masses, maritime air masses, are moist. They have moisture with them. When you take into account maritime and then compare it to, let's say continental. Continental, which is the C, and I talked about this in that diagram above as well, CT or CP, and there's a CT one right there. There's another CT here, CT, and then a CP or CA there. You'll notice that all the C's are located over land, and you'll notice that the M's are located over water, such as oceans. So when we look at the difference between them, maritime again coming over water, and then continental coming over land. And because it's mostly over land, these types of air masses are dry because they have no moisture that they're bringing along with them. Alright? So that's the example of when we're talking about moisture. Let's talk more specifically now about temperature. When we talk about temperature, air masses can change whether or not it's warm outside or cold outside. And many of you have experienced this firsthand while playing outside. Maybe you're an athlete, maybe you were just out maybe outside playing or swinging or walking through the woods, and you may notice that there was an actual change in the actual air. The reason why that happens, as you learned prior to watching this video, was dealing with the types of fronts. Was it a cold front that came, or was it a warm front? And now we can then connect the air that comes with that type of front that can change the actual temperature. So how do we know if the air mass is going to be warm or if it's going to be cold? And again, this is just like what we talked about with moisture. It depends on where it came from. So there are 5 terms that are used to describe whether or not it's going to be a warm air mass or a cold air mass. You have Arctic, polar, tropical, equatorial, and Antarctica. So these ones are examples of the terms that are used to describe whether or not something's cold or something that's warm. And I think just in simple terms, I think you already know which ones are going to be the warm ones. Tropical and equatorial, leaving the other 3 to define the air masses being cool. So we'll talk about the first one, Arctic. Arctic is going to be signified with a capital A. And what that means is that it's going to be coming from the north, and it's going to be very cold. Alright, Arctic being from the North Pole. And as you'll notice in this case, here's a CA1 located right here that will show that it's coming from the north and then traveling down into North America. And this type of air mass affects, say, Michigan, for example, mostly during the winter months. Very seldom do we have this type of air mass that comes during the summer months, mostly because of the tilt of the earth, and as we are receiving more direct sunlight, it doesn't allow for this type of air mass to kind of make its way down from the north. However, in the winter, when we're tilted away, and that receiving less direct sunlight would allow for that type of air mass to kind of trickle its way towards us. And these are those very frigid, below zero type temperature days when this type of air mass reaches, say, us in Michigan. When we're looking at Antarctica, the AA, we're looking at the air mass which now is coming from the south, and again is very cold. Alright, the same idea here is that when you're looking at this type of air mass that's coming from the specific part in the southern hemisphere. So this is a type of air mass that we don't necessarily see. Well, we don't see it all because it's coming from the South Pole, and it will never make it as it has to cross North America, the equator, headed towards North America. But nonetheless, that type of air mass does exist for those people below, south of the equator. When you're talking about polar air masses originate between the 40 to 60 degree north or south latitudes, and again, they're going to be cold. So anything that's connected with the P, for example, a continental polar air mass or a maritime polar air mass, are examples of things that bring cold temperatures with them. Then we look at tropical, for example. An area that has a tropical air mass, which is designated with the big T, comes from an area which is warmer. It's not near the equator per se, again, but it can be warm. Tropical air mass can start to originate from the equator, but that doesn't mean that it comes directly from the equator. It's simply just basically found, as you can see right here, tropical areas just to the south of North America, kind of originating Mexico and just above Cuba, Dominican Republic. Equatorial. As I mentioned just before, the tropical doesn't necessarily come from the equator. It can originate and start to move its way north, but the equatorial, which is the capital E, is an air mass that comes directly from the equator. So you tend to find that this is right specifically on the equator and is exceptionally hot. The reason why it's hot, tilt to the earth, this is the place on the earth that receives the most direct sunlight, no matter what the season truly is, just above or below the equator, but it receives the most direct sunlight, which then causes the air masses to tend to be mostly hot. Alright, so before we jump into the jet stream, let's do just kind of a quick little recap about the different things that can take place. Alright, the first of which, you have maritime, you have continental, you have tropical, you have equatorial, and you have polar. When we take these terms, maritime, continental, tropical, equatorial, and polar, we combine them to be a type of air mass that has both a temperature and a moisture content connected to them. So for example, you could have a maritime tropical, you could have a maritime equatorial, you could have a maritime polar. And in the case of a maritime tropical, it's moist and it's warm or kind of hot. In the case of a maritime equatorial, it's going to be moist and it's going to be hot. If you look at a maritime polar, it's going to be moist, but it's going to be cold. And I guess we could throw the last two in here, the Arctic or Antarctic, where you're dealing with a moist air mass which is very, very cold. You tend not to find these types of air masses all that frequent because it's so cold that the temperature of the air doesn't allow it to hold a whole lot of moisture with it. But nonetheless, you could run across that type of air mass once in a great while. Then you look at the other side. You could have a continental tropical air mass, which is a dry, warm air mass. You could have a continental equatorial, which is basically, again, a dry air mass that's over land, but it's quite hot. So you could be looking at places that are, let's say, in Africa, that are right along the equator, but not necessarily near water. And then you could also have continental polar. So this would be coming from the north portion of the world, kind of working its way down. For us, more like Canada, an air mass kind of originating over Canada. So it's going to be a dry air mass, but it's going to bring a lot of cool temperatures with it. And then again, you could have continental Arctic or continental Antarctic, which again is going to be a dry, very cold air mass. And again, these types of air masses will only come when we're dealing with our winter months.